I guess we could start by talking about this O'Reilly Data Science Handbook you wrote recently, and also this Python, what is it called? Whirlwind Tour through Python. I just read through that last night. It was 100 pages. Yeah, how'd you get involved in book writing projects?
Oh, man. So I got to know some of the O'Reilly editors via chatting at SciPy and PyCon and places like that. And I ended up being a tech reviewer for a number of books that O'Reilly put out, a number of Python books. And then, you know, the editors kept bugging me to see if I wanted to do a book project of my own. I didn't really have the time for it, but then finally, like, I've been given all these tutorials and doing all these classes at UW and things like that. And everyone always asks me about, you know, if I want to get into data science, in Python, what's the best book? And I didn't really have an answer. You know, there's some good resources out there. I think Wes McKinney's book is pretty good, but it focuses really on pandas and time series and financial modeling in particular. So I didn't have a good answer, so I decided to kind of take all my notes from my courses and tutorials and turn them into a book. So that was the genesis of that. So I created a proposal and went back and forth with the O'Reilly editor a little bit, and then finally signed a contract and started writing, and it took way too long.
How usually things go. I mean, I read through the outline, and also, you know, it's on GitHub and it's open on GitHub, which is cool. And yeah, I like your theme of it's really the first end-to-end thing, right? Because I mean, one of the issues with Python as a scientific ecosystem, as you know quite well, is that there is this in a way, right? I mean, now people have standardized on a set of canonical tools, but unlike, say, MATLAB and Mathematica, where, you know, you double-click install one thing, everything is mostly there. With Python, people have to get started with several different toolkits.
Yeah, and I think there's some cohesion there. Like, for example, if you know how indexing works in NumPy, then you're on your way to understanding indexing in pandas. It's you know, so there's some uniformity in that, and but you're right, it is separate packages that end up that people do have to learn. I don't think it's too much.
I think that's why it's important. Yeah, I think that's why it's important to have it all in one place in a book like yours, right? Instead of scrounging around on tutorials and Stack Overflow and various blog posts and everything.
Yeah. So I'm hoping it'll be a useful resource, and particularly I was excited about the idea of making all the Jupyter notebooks available. So I negotiated for that with O'Reilly in the beginning, and they seem to be willing to try that experiment of basically making the book's content free online.
Yeah, and what has been, you know, in your view, what's like their motivation as a traditional, say, book publisher to have basically a version of the book online for free in addition to the paper one? You know, why would book publishers want to agree to that?
Yeah, you know, so O'Reilly, turns out O'Reilly's been really a really big advocate of, you know, DRM-free digital copies of books since kind of day one. So you can, you know, when you buy, I believe when you buy an O'Reilly ebook, it's DRM free, which means you can, you know, share it and you're a little freer to use it. And so they kind of recognize, I was talking with some of their editors about this, they recognize the value in that, you know, not restricting users gives them, you know, more value in the product. And then and they've seen over the years that sort of thing doesn't negatively impact their bottom line, from what I've heard. You know, this is all secondhand. I'm not an O'Reilly person.
Yeah, I think that I think part of it is, I mean, I used to work at Google for a while, and companies have purchasing budgets, right? It's like every engineer gets $100 this month to buy whatever programming books you think are cool. So people will just spend that budget on buying paper O'Reilly books. If you notice, they're actually not super cheap, right? Some of the O'Reilly ones, even like a 100-page thing, is like $40. It's because it's corporately priced.
I mean, mine is even the discount on Amazon. It's like $50, so it's a little pricey in my mind. But you know, it seems like it's going well.
Yeah, so I guess maybe that's the ideal model, right? As an academic, is you have a free online version, but you have to have the publisher be happy and stay in business, you have a corporately priced publisher version, and people at Google can order, you know, 100 copies because they have a giant budget to order physical books. Yeah,
that sounds great. And for all people at Google listening, go ahead and order 100. It's a great idea.
Exactly. This is pays for the whole podcast. It's just my plug and we have some weird sponsor agreement or something. But yeah, I remember when I was there, like even as an intern there, they like let us buy, I don't remember. Either they gave us copies of books or they let us buy. I remember one that everyone got was Working Effectively with Legacy Code.
Oh.
It was, you know, the contents are kind of old, but the concepts hopefully remain.
Yeah, I should check that out. I haven't looked at it myself.
Like from the 90s or something. I think it's like, you know, here's your C++ code base or whatever.
Yeah.
So in terms of like the time commitment though, I mean, like, you know, you have obviously a day job where you probably have a lot to do. And how do you carve out the time to do book writing? I mean, this seems like a giant thing.
So I can tell you I did it much more effectively before I had a kid at home. That's one of the reasons that it got kind of delayed. I think the book was about a year later than I initially planned. But yeah, so I tend to be a morning person, like extreme morning person, ridiculous morning person. So I would just wake up about 4:45 or something like that, and head out to a coffee shop and do 3.5 hours of writing before I got to the office at a reasonable time. So that worked out well for me, and that's how most of the book got written, to be honest.
Yeah, my one of my friends from college, who I actually had on the podcast, he was a software engineer for many years, and what he wanted to do as a side project was to write a book about software engineering practices, and he interviewed all these engineers he knew in the Bay Area, mostly software and from startups, and he was working at Quora at the time, so just in downtown Palo Alto, and he lived down there, and he would just go to a coffee shop, like you said, for 3 hours every morning and write his book and then go to his job, and eventually he actually quit his job to do this book writing full time. And he got another job now, but he has this side thing where he has this engineering book he's promoting and he's giving talks on it and stuff. So he's this like engineering quasi-celebrity while working as an engineer now. But yeah, it all started with this, it's like this 20% time thing or 120% time, right? It's like you just have to make the time early morning to do it.
That's what worked for me. I've talked to other authors who do it differently, but I once I hit like 5-6 p.m. I can't work effectively after that.
Especially if you wake up so early. So I mean, another thing you mentioned was that you actually had course materials and training materials and talks and stuff all prepared. So it wasn't like someone's like, go write a romantic fiction novel from scratch, right? You had all this stuff.
There's a lot of adaptation of stuff that I had, but for example, the pandas chapter was entirely new. I didn't know. I only knew the basics of pandas before jumping in and trying to write that. I mean, I'd used it to do some analysis myself, but as far as kind of the comprehensive guide to pandas, that took a lot of research and a lot of reading what other people were writing and watching other people's tutorials to see what they thought was important. So that one was probably the bulk of the effort. The scikit-learn, the machine learning section, I've given so many 3 or 6 hour tutorials on that topic, both in the university and at conferences, that kind of wrote itself. That was pretty easy.
Yeah, I mean, talking about the pandas thing is interesting because you're coming from the perspective of you've obviously been a domain expert in this, but like you said, you were not a expert, yet you're writing on this chapter. I mean, in a way, I think it could be a good thing because you have a fresh pair of eyes on it and you're not Wes McKinney reading a billion pages on it. But on the other hand, how did you get feedback from others as you're writing it, or do you just rely on technical editors, in terms of the accuracy and the focus of that?
Yeah. I had a few technical editors through O'Reilly, in particular Tom Augsburger, He's one of the Pandas core contributors, was one of the O'Reilly technical editors. So I got a lot of great feedback from him. That was really nice. And he's so he was definitely offered some helpful feedback on that. Things that I was missing.
Cool. So I guess going back to the beginning, of the project, I mean, why did you decide to do this as a, in a book format rather than continue with tutorials and talks and blogging and all this stuff? Because you could disseminate the content in many forms, I assume.
Yeah, it's true. Part of it is the nice thing about a book is it gives you a deadline and it gives you someone who's hounding you to make sure that it happens. So a lot of that probably wouldn't have happened if I hadn't had that external pressure. Also, it's just the fact that, I want an O'Reilly animal, right? I think that's super cool.
Right.
I'm the Mexican bearded lizard guy, which is pretty fun. And I also was just really interested with experimenting with this kind of print/digital publishing format. See what can happen if you have Jupyter notebooks for the entire book, but also a print version. Because sometimes you want to execute code in your browser. Sometimes you just want a book to read on the bus or the train, right? And I think it's helpful to have both forms of that.
Yeah, I think and what about that whirlwind tour through Python, that like 100-page booklet thing? When did you do that relative to everything else?
That actually was the original first chapter of the Python Data Science Handbook. I wanted to start with kind of an overview. The idea with that is it's an overview for Python for people who know MATLAB or some other data manipulation language and just need to figure out the syntax so that they can understand reading Python and get into it. And it turned out that it was just a little bit too long. The book would have been 700 pages if we kept that chapter in. So we decided to take off that chapter and make it a separate free thing and make the printed book itself a little shorter. And narrow the focus.
This is always the prereq issue. I mean, I noticed this because we can also talk about your course, because I also noticed you taught this software engineering for data scientists course thing. And I was just reading very briefly online about the materials. And it's one of these things, the prereqs, so it's like we're assuming that you know some basic Python or MATLAB before you come in here, because we're not teaching you CS 101 from scratch. But yet there are going to be people who've taken, say, a CS. I mean, this is in all teaching, right? There are people who've, say, taken a CS 101 course, but it was in Java or it was in a long time ago, and they don't really have the prereqs, even though they meet the prereqs on paper. So, how do you deal with this issue of, where to start, right? In a book like yours or in a course like yours, knowing that not everyone's going to be up to speed, but you don't want to start at at A+B or whatever.
Yeah, it's really hard. And to be honest, I've done a lot of outsourcing to software carpentry on that. I don't know if you know the software carpentry organization. They do these amazing, basically 2-day workshops that are usually about 2 days that get people up to speed with everything from using Bash in the command line to using basic Python or basic R, and then they get into things like version control and stuff like this. And software carpentry has a really nice philosophy where they're trying to basically start with the very basic stuff. So a lot of people in the class might get bored because it's moving a little slowly, but they're trying not to miss anyone along the way. So through UW, we offer software carpentry courses about once a quarter. And so we get, usually have an R course and a Python course. So it's like 80 to 100 people a quarter that are doing this. And so we're able to, so for my courses, I tend to recommend software carpentry as a prerequisite. And then that people coming in have, they can navigate a file system in a terminal. They can push commits to GitHub. They can do those sorts of basic things. They can, read Python and maybe write a simple Python program. And at that point, we can start to dive into the little more interesting stuff like data analysis and simple machine learning and different software engineering tools that researchers use.
Yeah, I think this is an issue with everything. I mean, like even I teach these web programming and CS courses, and it's like, unless you are teaching the first course, people are going to have gaps in their knowledge. People are going to come with different levels of prereqs, whether people who've been hacking since they were 10 to people who haven't taken taken CS until they went to college. And these boot camp things are really interesting. So in cognitive science here, we have this like 1 week boot camp during orientation for people who want to do programming centered things. And grad students usually teach it, or we have staff kind of teach it. And yeah, these boot camp software carpentry things I think are key. And like I helped out on a software carpentry thing actually when I was at in Cambridge. It was at the Harvard libraries, and it was actually a bunch of librarians. And it was fascinating because this was like people who've pretty much never programmed before. And like you said, the software carpentry stuff is really good for nuts and bolts. Like even just, let's practice typing in 1 key at a time on the terminal and pressing enter and pressing tab and seeing what pops up, right? Stuff you don't want to take your time on in a course, but if people don't know how to do that, they're just going to be super frustrated that their terminal doesn't like show the right thing.
Yeah, and so it's nice to have that as a baseline, because it really helps people get up to speed to start exploring the more advanced stuff.
Yeah, so I guess kind of generalizing more, I've been just running through your whole CV, or just the parts of it I feel are most salient. So I want to talk, I guess, a bit about, the education type of work that you do, right? Because, presumably your day job is not fully as an educator, but you have obviously a ton of education stuff. You're teaching these courses, you're writing these books, you do training videos, you do these tutorials, these 6-hour tutorial things. So, how do you see that fitting into your life or job or role and such?
Yeah, so that's changed with the position I have now. So I'm currently at the eScience Institute at UW, and I've been here about 3 years now, and I have a pretty cool position here because the grant that we're funded with, they really want to recognize and promote data science education and development of software tools, open source contributions, and things like that. So roughly I spend about 50% of my time on like my own research, whether that's publishing in astronomy or working on an open source package or things like that. And the other 50% of the time is my institute duties, which involve things like teaching courses, teaching seminars, putting together educational materials and things like that. So right now it really, it's kind of like an integral part of my day job here at the eScience Institute. Before that, I was doing a lot of things on nights and weekends. When I was a postdoc, I had to get out papers, and I had to, work on whatever projects I had funding for. And so my open source contributions and my educational things were all kind of nights and weekends type of things.
That's really interesting. Yeah, I didn't realize that in your current role, the education part is an integral part, which is actually really cool, because it's obviously stuff you appear to really like doing and want to spend time doing.
We actually have some pretty cool programs where we're able to experiment. We have the freedom to experiment with how we do this. So what we're tasked with is to try to develop data science on campus for researchers, for students, whether it's professors or postdocs or grad students or undergrads, and we have various forms of that. But one of the things that was really cool is we have these open office hours for all our data scientists on staff. And so those are published on our website, and anybody in the university can come by and talk to one of our data scientists about a problem that they have. And then we have things that are a little longer term. We have this data science incubator project where people apply to work with one of our data scientists for 10 weeks in sort of almost like a pair coding mentorship kind of thing. And the idea there is it's a manageable chunk of whatever research project they're working on that needs some sort of input on the computational or statistical or machine learning side. And we sit next to them and get them kind of sped up so that they can go off and keep doing it on their own. So those kind of situations, or those kind of programs, are some of the really fun things that we're able to do here.
Awesome. And yeah, I mean, this data science consulting on demand thing is really cool, because when I was in grad school, we had this, they had statistical consulting, right, for a lot of things. The stats department, the grad students and postdocs, oh yeah, here's some posters, you can come by. But I don't know if many people use their services, or also it was always kind of one-off. Like, am I running this t-test properly? Should I use this two-tail or one-tail thing? But for you all, it's like much more about how do we structure the problem? What toolkit should we use? It's a much more end-to-end, which is awesome. It's not just, is this statistical test right? Which is what people go ask in stats office hours.
And we've also gathered in things like that into our program. So statistics has done these office hours for a long time, but now they're advertised on the same page and done in the same space as ours. Same thing with librarian office hours. There's the IT office hours. So different components of the kind of technical side of research are all represented in our office hours.
So wow. And is that all centralized in one place?
What's that?
Do you all have it in one place, like physically, or it's all just distributed?
Yeah, we have this data science studio, which is where I'm sitting right now. It's kind of an open space. I don't even know how big it is. How many square feet is this? It's maybe like 800 square feet, something like that. And it's an open space, open to anyone on campus. And we host these sorts of things here. Everything from office hours to workshops to those sorts of things.
Really awesome. I mean, it's an old school thing, but just the idea of having a co-located physical space with whiteboards and with, you know, the right environment is key. I mean, and having been at a few universities myself, I know that university real estate is like the hardest thing to get.
Yeah, it's true. And one of the reasons we've been able to get this space is because it's this interesting shift right now in the role of libraries in the university. Because libraries for years have been like warehouses of books, maybe glorified warehouses of books. And now the printed books are not quite as important as all the digital literature and digital resources. So at UW in particular, there have been all these subject area branches of the library, like a math library or an engineering library or physics library. And those are getting harder and harder to justify because they're not used quite as much. I mean, 30 years ago, an astronomer who needed to do a literature review would go to the astronomy library and look through stacks of journals, right? And now they do a web search on the astrophysics data system. So what happened is they were trying to figure out what to do with this, in this case, the physics astronomy library space. And we were able to move in partnership with the libraries and say, like, this data science thing, this dealing with and helping people learn about using data effectively is a key component of the library's mission, and we're helping out with that. So we've teamed up, and that's where the space came from.
Yeah, that is really awesome. I mean, I would love to have that sort of stuff down at UCSD. I mean, we you know, like everybody, we're trying to start data science stuff, and there's all this talk about it, but space is a giant concern, right? I mean, ideally you'd have your own space like this, because otherwise it's distributed. I mean, having it in concept is good and saying, oh, here's a web page. We have 10 researchers and data scientists and statisticians. You can come to our office hours. But if it's like, literally, we are all there 4 to 6 p.m. Fridays, hanging out on this space, come by. It's just, it's so different.
Yeah, and that works pretty well here. And there's also open space for people to just study on their own, so they can come by and hang out. And the other benefit of it is this is a beautiful space. I don't know, this is probably not going to work looking out the window, but I have a 6th-floor view out over in the distance. Those are the Olympic Mountains, and if we go to the south window, I get to see Mount Rainier. You know, so we have a place that's nice to hang out too.
Yeah, it's a clear day too. I mean, it's also we caught you on a clear Seattle day.
Yeah, you know, it's always sunny in Seattle.
Yeah, that's right. It's always sunny in Seattle. Got to promote your book. You'll flash your ISBN code up there. This is great. Yeah, I guess we got a few more minutes to wrap up. Let me see what else is up. Yeah. So how did you get involved with this Altair thing? Because this seems like I've been following this loosely. So how did you get involved in this? Because this seems
so Altair. Let me just say real quick what it is. So Altair is a new declarative visualization library for Python, and it's built on top of these tools that you might know called Vega, Vega Lite, and D3. So the idea there is that D3 is this thing that's really, really powerful and drives pretty much all web visualizations you see out there. But it's really low level and really hard to use very well. So the people behind D3 started making this Vega grammar. And what Vega is it's a declarative grammar that allows you to specify visualizations at a bit more high level that are then visualized like D3, interactive online. But it turns out Vega itself is pretty verbose as well. So once Vega was mature, they started working on Vega Lite, which is a JSON grammar that is a little more terse than the Vega grammar and allows you to create statistical visualizations. And we saw that developing. It's out of Jeff Hare's lab, who's here at UW working in the computer science department. And I thought it was really intriguing, but the problem is I don't want to write JSON structures by hand, right? So I got together with Brian Granger and a couple others down at this data structures for data science meeting that we had about 1.5 years ago at Berkeley. and we decided to try to put together a Python wrapper, or a Python API that would generate this Vega-like code and create interactive online visualizations. So we've been working on that, and it was really Brian's vision. So Brian Granger is one of the co-founders of IPython and Jupyter, and has been very active along with Fernando in a lot of this stuff. And his vision was to create this Altair wrapper for Vega-Lite. And I've been pushing on it because I think it's a great idea. And the hope is that that Vega-Lite can be some sort of kind of a lingua franca between different visualization tools. So you might have, for example, Bokeh spit out some Vega-Lite that could then be interpreted by Matplotlib, or even some of the tools like ggplot or ggviz could output that sort of grammar. So yeah,
it's not just different tools; it's different languages too, like you mentioned. I mean, I think folks have been talking about inter-language interoperability for data science, and having a would be nice for that.
Yeah. So that's the idea with that, and then we've development is sort of stalled a little bit right now because we're waiting on the Vega-Lite 2.0 release, but that should be happening by probably March at the latest. So it's getting really close. And then once Vega-Lite 2.0 is out, we can really dive in and start making sure the Python wrappers are there. And this is going to be 2.0 is going to be really exciting because on top of having this grammar for expressing graphics and expressing relationships between data and their visualization, this also is going to have a declarative grammar for interactions. So you can in a very concise and intuitive way specify how the interactive features on your plot interface with the data that you've given to it. So I think this is going to be a real game changer in the Python interactive database world. So I'm pretty excited.
So you're saying Vega-Lite's going to have the reactive, the interactive stuff, and then you're going to put Altair on top of that?
Yeah, exactly. So Vega-Lite is going to include this grammar of interaction, which to my knowledge has not really been done before. This is kind of a new contribution. People have been thinking about declarative visualization for a long time, but declarative interactions is kind of an exciting new area of research in the visualization community, and we're going to be able to have that in Altair via Vega-Lite.
Nice. Yeah, and I think that going back to the theme in the middle and the beginning about the forcing functions, right? How having a book publisher kind of prod you is a good forcing function. So you and Brian and the Altair folks are kind of the forcing function for the Vega-Lite folks, because they're grad students and academics building this. So if you all pushing on we want this to be for real and good, then don't just graduate and leave and don't maintain it.
And we're getting the cool thing is that Vega-Lite is getting a lot of users via Altair, so that's pretty nice. They're growing their user community that way. So it's been really fun to work with them. It's a great team.
Yeah, I think that's really cool too, because like you said, I think it provides a really powerful bridge. Because I saw some of Brian's talk, like initial talks on Altair, and it's like we're not going to build our own D3 from scratch. We're just gonna, we're gonna have a Python layer on top of this great JavaScript thing that already exists. So it just makes a lot of sense to just be able to extend that to the entire Python ecosystem, especially with the Jupyter notebooks and everything is web-based. So it is super exciting. I mean, now I'm like super jealous because I was doing this quote unquote data science-y stuff in grad school 10 years ago, and it was like so painful, like the sets of tools we had back then. And now it's like, wow, for students coming up now, it's like, wow, I feel like an old guy. It's like, you guys have it so easy.
Yeah, it's matured a lot. I remember starting to work. I started working with Scientific Python in about 2006. Man, there was some rough edges for sure, and a lot has happened since then.
Cool. So we'll just wrap up, and we'll chat a little bit offline. Thanks again, Jake.
Yeah, thank you.